Assalamualaikum and good day, ladies and gentlemen. Today, we will discuss the comparative analysis of Superpixel and Gabor method for exudate feature extraction in diabetic retinopathy fundus images. Diabetic retinopathy is a prevalent health issue associated with long-term diabetes, often leading to various complications. One characteristic of diabetic retinopathy is the development of exudate in the retinal region. Fundus image analysis serves as a common method for diagnosing diabetic retinopathy, relying on the expertise of ophthalmologists. However, computer-assisted diagnostic tools have enhanced the speed of diagnosis, provided diverse perspectives, and evaluated treatment outcome. Exudate appear as bright lesions in retinopathy images and have sharp edges and high contrast with the background. As you can see in the image, they commonly appear in the initial stages of diabetic retinopathy and can act as possible discriminant predictors of disease severity. Various techniques for detecting exudates, including the mathematical morphology, dynamic thresholding, and morphological operation have been proposed. Next is a problem statement. Majority of exudates are scattered in the fundus image, thus it's hard to be extracted with the presence of vein, thick disc, fovea, aneurysm, or even hemorrhage on the image. The objectives of this research is to extract the exudate features using the Superpixel and Gabor method in fundus retinal images. The researchers aim to compare the performance of the Superpixel method and the Gabor method in accurately extracting exudate characteristics. Then we determine the accuracy of the Superpixel method and the Gabor method in exudate extraction from fundus image and highlight the potential of the Superpixel method in improving diagnostic accuracy and efficiency. For the research background, the exudates are accumulations of lipid and protein in the retina, indicating increased vessel permeability and associated risk of retinal edema. The exudate detection technique based on mathematical morphology have been proposed, which are fast and require lower computing. Incorrect exudate detection can occur due to artifact, low contrast exudate, or proximity to blood vessels. Standard edge detectors like Sobel and Kenny are not suitable for extracting exudate edges due to noise and missing the key edges. Hard exudate are distinguished by form variegation and sharp edges. Therefore, it is preferable to take exudate boundaries into consideration when creating reliable and precise detection algorithms. We use a total of 189 retinal fundus images, 133 of which exhibit the exudates, while the remaining 56 images are healthy retina. Retinal fundus image data used in this study were obtained from public databases, including the Standard Diabetic Retinopathy Database, Indian Diabetic Retinopathy Image Dataset, Public Database, and High Resolution Fundus Image Database. Two alternative approaches for the feature extraction were used: the Superpixel method and the Gabor wavelet method. The first method, Superpixel method, employ the superpixel to group pixels based on similar values and divides the object into sections, enhancing pixel interpretation without distortion from other image processing effects. And the second one, the Gabor filters are well suited for texture segmentation issues because they have the best localization characteristic in both the spatial and frequency domain. These are the processes that we have done to extract exudate from the fundus image. First, Superpixel algorithm is applied to input image with n equal to 500. Then this value is varied to 900 and 1500. After that, we mask the fundus optic area, then apply contrast limited adaptive histogram equalization, or we call it CLAHE. Next, select green channel from the RGB image and apply OTSU thresholding with 140 threshold value. Then we draw the boundary of exudate with green color and then calculate the total number of pixels, which is the total pixels area, and also the perimeter. Next is a method for the feature extraction using Gabor method. The input retina fundus image is we extract the red channel of the RGB image. We only use the red channel and then apply with a Gabor wavelet to produce the magnitude image. After that, we segment this image using a combination of algorithm, which is the Gaussian, filtering, plus with the PCA, and finally K-means. We get the output as you can see in the figure, the blue colors like this, and then the output is actually the red color here, segment output that contains exudate. Okay. After that, we use the threshold method using OTSU, okay, with the value 50. Next, we draw the boundaries of the detected exudate with the blue color. And then finally, we calculate all the parameters, same as method that we use for the Superpixel. We employ a manual approach to testing, where testing images were compared to corresponding ground truth images. The validation process involved calculating true positive, false positive, true negative, and false negative rates to assess the performance of the exudate detection method. The result shows that the detection achieved excellent results using the Superpixel feature extraction method, with an accuracy of 90% and a sensitivity of 89.13%. On the other hand, the Gabor features extraction method exhibit lower accuracy, specifically 78.3% with a sensitivity of only 79.86%. As you can see in this image, we have the ground truth image, and then the result of the Superpixel method at the center, and the result of the Gabor method. The Superpixel method outperformed the Gabor method in accurately extracting exudate characteristics. Here, some isolated exudates were not detected in Gabor method, while most of the exudates were well detected in the Superpixel method. In conclusion, the comparison between Superpixel and Gabor feature extraction methods highlighted distinct outcome in exudate feature detection. The Superpixel method exhibits superior performance with higher true positive and true negative results. The Gabor method shows slightly lower results. Visual results showcase the successful exudate extraction using both methods, affirming their effectiveness. The Superpixel method's superiority suggests reliability in identifying exudate features accurately and sensitively. Findings contribute to retinal image analysis and advancement and potential enhancement of ophthalmology diagnostic. Further research and refinement could lead to increased precision and efficiency in exudate detection. Thank you for listening.